We're going to do a quick review. We're going to do a quick review over
I feel like Megan Box in the
what
test.
you're supposed to know. Okay? Alright? So,
You don't. It's pretty solid.
we're fixing to do 5.3. Hush. Which is solving trig equations. Okay? That's the name of this section. Now notice I skipped over to chapter 5. We've been in chapter 4 for forever. And now I just skipped over. I like to pick this up because it is just like what you've been doing, but it's a tad bit different. Alright? So here's the one thing that I want you to do. Remember your restrictions. Okay? Remember your restrictions. So just so I can reassure myself, all right? Let's go right here and let's, in tiny little letters, let's write our restrictions. The inverse sign is restricted to quadrants
1 and 4.
very good. He is positive in
1.
and negative in
4.
The domain is restricted from
Negative 1 to 1.
very good. The range is restricted from
Negative
Negative pi over 2, pi over 2.
very good. Negative pi over 2 to pi over 2. That goes from that quadrant 4 to that quadrant 1. All right? So, are you with me? Is your brain thinking back? Okay? All right, so inverse cosine. Quadrants
1 and 2.
1 and 2. He's positive in 1 and negative in 2. That's the one that you have to put in quadrant. That's right. You've got to put him in that quadrant. Up here, if it's negative, you do what to it? Slap a negative on it. Okay? What is his domain? Restricted to what? Negative 1 to 1. Okay? What about his range? 0 to pi. Very good. Bailey's over there. Usually she's like, oh, I don't know what's going on. And this year, today she's like spouting off every answer we got. So inverse tangent quadrants. 1 and what?
4.
1 and 4. He's just like the sign. Okay? If he's positive, he's in quadrant 1. If he's negative, he's in quadrant 4, and you're just going to slap a negative sign on it. Okay? What about his domain? Negative infinity to positive infinity. So he really has no restrictions on there. He can be anything. You with me? What about his range? Negative pi over 2 to pi over 2. Just like inverse sign?
Exclusive.
Exclusive, because those are my what? Asymptotes, okay? So it can't be those outer points. Negative pi over 2 can't be on that axis. Negative pi over 2 to pi over 2. Those are the asymptotes, so they're excluded, not included. Okay? So remember your restrictions unless, here it comes. Otherwise, okay, and I can't think of the right word. So this word kind of sounds silly, but I can't think of, for lack of a better word, I'll say notified.
A lesson formed.
Okay? So, unless I tell you, y'all listen to me. If nobody says anything about the restrictions, these are the restrictions. Did anything say anything about restrictions on that worksheet? No. Nothing about restrictions. How many answers did you get for each one? One. Right? Positive in the first quadrant, negative either in quadrant 4 for inverse sine and tangent, slap a negative on it, or quadrant 2 for inverse cosine, where you had to put it in that quadrant. Are you with me? Okay, so what are they going to do? Y'all, they're going to do the same type of problems, but they're going to change the restrictions on you. Okay? They're going to change the restrictions. These are the given restrictions. So if they don't say anything about it, this is what you're doing. On your 50-point test on Wednesday, this is what you're doing. It is like that worksheet, that's why I wanna get your worksheet graded and handed back to you before you take that test, so you can see if you're messing up on something, okay? So, let's look at the first one, example 1. Solve 2 sine x minus 1 equals 0 over the interval 0 included to 2 pi excluded.
That looks.
Okay, so why would I include 0 and exclude 2 pi?
2 pi is your asymptote, 0, it could be on 0.
No, try again.
It's 2 pi your
Because you wrote it in brackets.
It could be 0, but 2 pi is
What?
asymptote.
Over
Through the what?
Interval.
What'd you say?
Because it will complete the period, it's over the middle.
Yeah, what are these 2 things?
Period. 0, third 360.
Restriction.
Are these the same thing, 0 and 2 pi? People, they're the same thing. Why would I include both of them? Do you see what I'm saying? 0 and 2 pi are exactly the same thing. Okay? Do you understand that? Yes or no?
Yes.
Here's 0. Guess what this is? 2 pi. Oh, what? He's the same place as 0. Okay? So I include 0. I don't include 2 pi. So 2 pi will never be an answer. What's the answer?
6.
0. Alton, stop. We're recording. Don't confuse people. Okay? All right. So here we go. We're going to solve this equation over this interval from 0 inclusive to 2 pi exclusive. Okay? So I'm going to solve this. People, this is like an algebra 1. This is what you're solving for right here.
Yes.
Okay?
Plug in 0.
So tell me what to do. Plus 1 to both sides. Very good. So now I have 2 sine x is equal to, what's 0 plus 1? 1. Now what do I do? Yes, divide by 2. Get that by, if y'all, you solve for it means give me by myself. Okay? So divide by 2. So now I got sine x is equal to 1/2. Are you with me?
Yeah.
Okay, so here's where the rules come in. The very first thing, okay, now I'm going to tell you what I would do if I were you, okay? I think we'll do it, and I'll just put it on another sheet of paper, okay? And then when I need it, we'll just pull it out and use it. All right. I would do a little first quadrant thing, okay? Are you with me? So here's 45, so this is pi over 4. This is pi over 6, that's 30. And this is 60, he's pi over 3. You ready? What is the point at pi over 6?
Pi square root of 3 over 2, 1/2.
Very good. So what's the point at pi over 3?
1/2 square root of 3 over 2.
Yeah, he's just flipped. Oh, crud. Okay? Now, what is the point at pi over 4? Yeah, and that's the way I would write it. You can write it as square root of 2 over 2, but remember when you flip it, sometimes that creates an issue for you. Y'all forget to reduce it. I would also put these points right here, there, because these are the points that deal with quadrant angles. Do you understand? So what is this point right here?
1, 0.
And this guy up here?
0, 1.
And this guy right here?
Negative 1, 0. 0, negative 1.
Colton, please tell me that you did not take that off the bottom of that table.
Oh, no, this is from engineering.
Oh, okay. I was like, I thought it was gum. I thought it was gum. You took off the bottom of that table.
No,
I was
this is
like,
extra nose
what?
mask.
And are you chewing it too? No.
No, that's not
Stop.
ours.
Okay. So, another thing I might write on my paper is, I'm gonna write it in a different color, I might do this. All students take calculus. Y'all know what that stands for, right?
Yes.
All are positive in the first quadrant. In the
Sine.
second quadrant, sine and his reciprocal,
Tangent.
what? Cosecant are positive. In the third quadrant, tangent and his reciprocal cotangent are positive, and cosine and secant, his reciprocal, are positive. So we're only talking about the positives, everything else will be negative. Okay? So this is what I'm gonna do to work the problems. Alright? Notice, okay, that's all I'm gonna say. Alright, so here's the questions you're gonna ask yourself. Where, there's three questions, or three things.
What sign?
Where does it have that sign? And that's S-I-G-N, okay, positive or negative. Who is it? Okay, and then the last thing you'll do is put it there. So essentially, everything that we're fixing to use, you already know how to do, okay? So, it's just another way. Now, I hesitate teaching this to you before that 50-point test, but I'm gonna tell you before the 50-point test, and I'm gonna tell you multiple times today, and all that kind of stuff. People, how many answers did you get for your problems that you did on your worksheet on Friday? One. Okay? I changed the restrictions. It's going to have more than one answer now. Okay? On the 50-point test on Wednesday, will there be more than one answer for each blank?
Yes.
No. I'm not changing the restrictions. You're going back to these restrictions right here. Okay? Unless they tell you otherwise, these are your restrictions. Okay? These are the restrictions the calculator uses. Your calculator is a function-based utility. You can't have multiple answers to one problem, right? He didn't go this, or, oh, by the way, it could be this.
That's
Or
what I
what
do on
about
all my
this?
tests.
So, no, it doesn't do that. All right, so here we go. The first thing I'm gonna ask myself, I'm right here, I just solved for sine x. Y'all listen to me. This right here, I'm not gonna rewrite it that way, but I'm gonna tell you. This right here is the same thing as this. The inverse sine of 1/2 is equal to x. The sine of what angle is 1/2? The sine of what angle is 1/2? These say the same thing, okay? I'm not gonna rewrite it. All right, so you gotta ask yourself these three questions, okay? So the very first question is where? Where is sine, what is this guy, positive or negative? Where is sine positive?
Cosine. I mean,
Quadrant
1
1
and 2.
and quadrant 2. Are you with me? Now, who has a sine of 1/2? Pi over 6. Okay? So, oh, sorry. Pi over 6. So put pi over 6 in the first quadrant. What is it? Pi over 6. Put pi over 6 in the second quadrant.
7 pi over 6.
No, 5 pi over 6.
5 pi over 6. Okay? So, think about this, okay? So, y'all, this is 1 pi right here. This is 1 pi. If you want to go to the second quadrant, you back it off 1. If you want to go to the third quadrant, you push it forward 1. So, if I'm talking about sixes, pi over 6, I want to put it in the second quadrant. This is 6 pi over 6. That's 1, 6 over 6. 6 pi over 6, back it off 1, and where are you in the second quadrant?
5 pi over 6.
5 pi over 6. Push it forward 1, and where are you?
7 pi.
7 pi over 6. Over here, this is 2 pi.
9 pi.
So double that denominator. 12 pi over 6. 12 pi over 6. Back it off 1 and put it in the fourth. 11 pi over 6. Okay? So you do the same thing to pi over 3. This becomes 3 pi over 3. Back it off 1, and where are you? 2 pi over 3. Push it forward 1, and where are you?
4 pi.
4 pi over 3. Over here, you're 6 pi over 3. Back it off 1. 5 pi over 3. Are you with me? Caleb?
So then on the 50-point test, it's not gonna give us the equation, it's just gonna go like
Yep.
the inverse
Inverse
sine
sine
of
of
1/2.
log. That's
And then
exactly
it's gonna
right.
answer, and then for whatever this is, it's gonna give you. the
Because I
equation.
changed the restrictions right here. This is the important part right here. See, these are restricted right here. I changed the restrictions to include the whole entire coordinate plane. So that means every time it's positive, it's gonna have 2 answers. Why? Because it's positive in 2 quadrants, and it's negative in 2 quadrants. You see what I'm saying? That's what's giving you those multiple
Will it
answers.
always be the interval of 0 to 2 pi?
Yes. Anytime they change the interval, that's what they're gonna change it to.
So you'll always have two answers for the equation.
Yeah, we're gonna talk about if it's different from that, but I'm not going to today. Okay, but it's really easy, it's just a little glitchy thing. Okay, so what are my answers? Pi over 6 and 5 pi over 6. Those are my two answers. You got me?
I got you.
Everybody good?
It's over?
Wait, that's the full question?
Oh.
Now, let me show you something cool. Now, on the test, I don't think, I'm not sure, but I'm gonna show you how you can check this on your calculator if you want to, okay?
I want to.
Okay, so first of all, what do I have to make sure about my calculator?
It's in radians.
It's in radians, so I'll press the mode button, he's in radians, good deal. So I'll quit. Now, all I'm gonna do is plug these two answers back in, one at a time. So I'm gonna go 2 times the sine of pi over 6. And then minus 1. What's it supposed to be equal to, people?
0.
0. So you say, please, Lord, let it be 0. Yes. Ooh.
Oh.
That's one of my answers. Now I'm going to check this guy. 2 times the sine of 5 pi divided by 6. Minus 1. It's supposed to be 0.
Have you ever had a blueberry donut? They're so good.
Okay, that's not what we're talking about.
On the
Thank
test,
you.
will you let us use the calculator?
I'm not sure. On one part of it I will, and part of it I will not. Okay?
So there won't, there'll be like a calculator part to this?
Yes.
Alright.
So example 2, here we go. Solve
That's how you know it's good.
sine x plus the square root of 2 is equal to negative sine x over 0 to 2 pi. Okay? So as soon as they do this, they change my restrictions, right? Now I know I could possibly have multiple answers. All right? So I'm solving for sine x. Guys, the object of the game is to get whatever the function is
By itself.
by itself. That's exactly right. So tell me what you want to do.
Divide square root of 2. Or subtract it, I'm sorry.
You wanna add the sine x?
Minus on
Yeah, I'm just gonna minus sine x, because I don't care which side it's on. Some of y'all don't like that, because you don't like it to be on the right. But there's nothing wrong with it, okay? So I'm just gonna minus sine x. If you wanted to add sine x and then subtract the square root of 2, you'll get the same answer we do. Okay? So these go away, and I'm left with the square root of 2 is equal to, what's negative sine x minus sine x?
Negative 2 sine x.
Very good. Negative 2 sine x. Like signs, you add and take the sign above. Okay, so now what do I do?
Negative.
Divide by what?
Negative 2.
Negative 2.
I don't want to be wrong.
So now I have sine x is equal to negative square root of 2 over 2. Now what's your brain screaming at you?
Pi over 3, pi over 3.
Stop. I don't want to do, no. Okay, don't be saying that. Okay, so what is this the same thing as?
1 over the square root.
Yeah, this is the same thing as negative 1 over the square root of 2. Okay? That's what I wanted your brain to scream at you. Alright? And to recognize that these two things are the same thing. Remember how I said at some point, if you don't understand that those are the same, it'll hurt you? Okay? So we're getting to those points, so you need to be careful. Alright, so what's the first question we're going to ask ourselves?
Why did you write
Where?
Quadrant 3 and quadrant 4.
Where? Where is sine negative?
3 and 4.
3 and 4?
Okay, so I'm in quadrant 3 and quadrant 4, okay? Who has a sine of 1 over the square root of 2?
By 4.
Pi over 4. Put pi over 4 in the third quadrant.
He is
5
5
pi over 4.
Very good. So that's my first answer, 5 pi over 4. Put pi over 4 in the fourth quadrant.
7 pi.
7 pi.
7 pi over 4. Double that denominator and then back it off 1. 7 pi over 4. So those are my solutions.
Wait, your denominator's on top?
What?
You said double the denominator?
Double the denominator, 8, and that goes on top, and then back it off 1.
Oh, okay.
Because 8 over 4 will make 2
That's
pi.
for the fourth quadrant? You double the denominator?
Yeah, for the fourth quadrant, you double the denominator, because that's what's gonna make 2 pi, and then you're gonna back it off 2. That'll- Do you want to do by yourself?
No, I won't by myself.
Okay, I'm gonna give you the next one by yourself, but I'm gonna warn you about this.
Well, not if it's different.
There's gonna be something that you might mess up on, okay? So here's the next one. Are you ready? But I mean, even if you mess up on this one little thing, it'll be okay.
Tangents.
Why are you putting tan in there?
It doesn't matter.
And a 2, what does that 2 mean?
Square?
I know that. I knew what that meant.
Gary?
I was just asking for the people watching.
Now what, okay, you do it. If nothing else, then solve for what? Tangent. Not tan squared, but tangent. Okay, so I'll give you a minute.
It's time to retire.
What's the square root of 64 on here?
How would you have 60
What the heck?
I feel as if I'm lost.
I must have looked at it really wrong. You got 64.
He's wrong.
Okay.
I'm not wrong, I just didn't get that at all. I was just messing with y'all. No, I'm not though, because I know what I'm doing.
What do you, if you're using this right here, what do you have to know about tangent? Tangent is what?
Y over X.
Y over X. That's what you have to know about tangent. It's Y
Can you leave
over
that
X.
right there?
Wait, y'all are supposed to have this.
I know, but I do it right now. Okay. How have I got anything on that?
All one square.
Where's the square root?
Tan x equals 1.
Someone didn't even you didn't even solve the equation right. That's pitiful, bro.
Bring it out.
Okay, so let's go. Here we go. The first thing, what's the first thing I'm supposed to do?
Add 1.
Add 1.
Yes, add 1.
So tan squared x is equal to 1. Now what am I supposed to do? Square root. Okay, so here's where the mistake's gonna happen. So what's the square root of tan squared?
Tangent x.
Tan X equals 1.
Oh, no.
Plus or minus?
That's exactly right. Plus or minus 1. So remember back in Algebra 2, when your teacher told you, if you're ever solving an equation and you take a square root, you must put the plus or minus. Okay? If you don't put the plus or minus, then you'll miss half of the answers. Okay? Because
Oh, I remember that.
where is tangent positive and negative?
1, 2.
There you go. 3 and
3,
4. Okay?
Wait.
So he's in all of those quadrants.
Positive and negative.
Positive, because it's plus or minus. The square root of 1 is plus or minus 1.
So if it's a plus or minus anything, it's in all.
It's in all 4 quadrants. That's exactly right. Okay? So tangent is y over x. So I'm looking to put a y over an x and it'd be 1. Y'all, if it's 1, what do you know about y and
Pi
x?
over 4, same.
Yeah, they have to be the same. So it has to be pi over 4. Okay? So what is it? Pi over 4. Put pi over 4 in the first
3
quadrant.
pi over 4.
In the first quadrant.
Oh.
Then 3.
In the second quadrant.
3 pi over.
In the third quadrant.
5 pi over 4.
And in the fourth quadrant.
7 pi over 4.
Perfect.
I don't understand.
Okay? Anybody got a question? Okay, so we got 2 more problems to work. Alright, 2 more problems to work, and y'all, the bell rings in
10, 15
how many?
minutes.
12 minutes? Oh, we're good. Example 4. Okay, so watch this guy.
No.
What the?
I don't think we're doing this one by ourselves.
Okay, so when you look at a problem, the first thing that you notice about this problem is what?
3x.
Yeah, there's 2 different functions. So that, then you're like going, whoa, how can I solve for one of them when there's two different
You
ones.
cancel out the coaching.
Okay? No, listen to me. Here's what you need to do. The object of the game is to try and separate them. Okay? Now let me tell you what a mistake would be. Then this morning one of the kids said, oh, I know, Miss Davis, you can just divide by cotangent x, and then that one goes away. Is that true?
No, that turns into 1.
Yeah.
That does go away, because 1 times anything is that. That does go away, but you get rid of one of the answers when you do that. Yes, because there's cosine and cotangent, that's our problem. But if you divide by this one and make it go away, you'll throw one of the possible answers out. Okay, so that's not the way to do it, all right? So what you want to do is, I want to find a way to separate them. Yeah, I'm going to factor it, okay? I'm going to factor it. If I can factor it, okay, now whenever you factor things, what do you want them to be?
Equal to each other.
What do you want them to be equal to in order for it to be beneficial to factor?
100.
0?
Thank you. 0. Tyler said make it equal to 0. Because then, when I factor it, what do I do with each one of those factors? Set each one of them equal to 0, and then you can solve each one. Okay? Do you see what's happening? So I'm using skills from chapter 4 in Algebra 2 is what we're doing. Okay?
I like this.
So let's take this guy and move him over here. Let's subtract him from both sides. So I'll get cotangent x cosine squared x minus 2 cotangent x. Okay, so if I'm going to factor, remember the very first rule of factor says, look at them and see if they have something in common that you can take out. What do they have in common that you can take out? Cotangent. So let's take a cotangent x out. What do you multiply cotangent x by to get cotangent cosine squared? Cosine squared. What do you multiply cotangent x by to get negative 2 cotangent x? Negative 2.
Wait,
What's
what?
another way of factoring, guys? Factoring is the same as what?
Dividing by.
Dividing. So look, let me show you what happens. If I took this guy right here, cotangent x cosine squared x, and I divided by what you're factoring out, cotangent x. You see how these guys go away? And that's what you're left with. Okay? This guy right here, negative 2 cotangent x divided by whatever you're factoring out, cotangent x, these go away, and there's my negative 2. Are you with me? All right. So, so I just factored. Now, what do I do with each one of those factors? I set it equal to 0. Okay? So, I'm going to set the first one equal to 0. Is it'll look like this. Cotangent x is equal to 0, or cosine squared x minus 2 is equal to 0. Okay? So, let's go do this guy first. Okay? So, what is tangent? Y over x. So, cotangent must be what?
X over Y.
Okay, so this is x over y. So, really what I'm looking for is, where is x? 0. Do you agree with that? So, I'll look at that little drawing. Where's our little drawing? Okay, here he is right here.
Quadrant angles.
Where do I have, okay, so let's talk about that for a second, because I meant to mention it on the last problem. Y'all, anytime I see a 0 or a 1, what's my brain screaming at me? Quadrant angles. The only exception to that rule is 1 and a tangent. That's a 45, okay? So anytime I see a 0 and 1, my brain goes, oh, that's a quadrant angle, and then I look and check. If it's a tangent and a 1, that's a 45. But other than that, every one of them are quadrant angles. Do you see what I'm saying? Okay, so as soon as I see this 0 on this guy right here, I go, oh, this is a quadrant angle. And if the fraction, I want the fraction to be equal to 0, then the top has to be 0, right?
Correct.
You see? So where is the x equal to 0? Well, that would be these two guys right here. Do you understand? So that would be what? And 3 pi over 2. Okay? So that would be pi over 2 and 3 pi over 2. Are you with me? Sean?
That's not in your range.
Oh,
Did you forget to?
over the interval 0 to 2 pi. That's all we're doing today, okay? So all of them are gonna be that way, but thank you, I should have written it. All right, so this guy over here, now let's work him. Tell me what to do.
Add 2.
Add 2. So I get cosine squared x is equal to 2. Now what do I do? Square root both sides. So cosine x is equal to, what's the first thing you should write down?
Plus or minus.
Plus or minus. Plus or minus the square root of 2. So obviously it's in all 4 quadrants, do you agree?
Yeah.
So who has a cosine of the square root of 2?
No.
Oh, that's very tricky, because that's what they're doing. That's what they're trying to make you think, pi over 4. But is the x-coordinate of pi over 4 the square root of 2?
No.
No, it's what?
1 over.
1 over the square root of 2. You see what they did?
Nope.
Like they played a mind game with you, didn't they? They tried to trick you. They used a number that you're familiar with, so it made you go pi over 4. But y'all, that is not the x-coordinate of pi over 4. The cosine is x. So, here it is, pi over 4. There's cosine, and there's y. Is 1 over the square root of 2 the same thing as the square root of 2? No, it's not. Okay? So, who has a cosine of the square root of 2?
Nobody.
Nobody. Very good. Empty set. Y'all, what is the square root of 2?
Something.
1 point something.
Yeah.
1.41.
1.41? 42? 4142? I don't remember. 414, we'll say. All right, so 1.414. Y'all, what is cosine's domain?
1.
Negative 1 to positive 1. So what do you know about plus or minus 1.414?
Doesn't fit.
He's outside your domain, people.
But if it was a secant, it would be right.
Yes, if I had done secant, it would have been okay.
I thought you said it didn't matter if it was outside the domain because you changed it.
I changed the range. The angles are the range and the numbers are the domains. Okay, remember that? Domains go from negative 1 to positive 1 for sine and cosine. All right? But the ranges are always the angles. Negative pi over 2 to positive pi over 2 and 0 to pi.
Sounds like a good old day to me.
I have no idea.
So my only answers are what? Pi over 2 and 3 pi over 2. All right, so here we go. We just got about 4 minutes, so let's do it. Example 5.
Let's do it.
2 sine squared x minus sine x minus 1 equals 0. Hello, quadratics. Okay. So, some kids can look at this and they're okay with it. Some kids' mind goes,
Does that say sine?
sine. Some kids' minds can't look at that yet. They're just not ready for it. So if you wanted to, I can replace this with a variable. I'm gonna put an a there. This is the same thing as 2a squared minus a minus 1. Do you see that?
Oh, it doesn't look bad.
Oh yeah, so you
Yeah,
factor
so
it out?
can you factor this?
Yeah.
What does 2a squared factor into?
2.
2a and a? What's a minus sign at the end mean?
Different signs.
Yeah, one's a plus and one's a minus. What are the only factors of 1?
6.
1 and 1. Wait 1 second.
Always check your inners and outers. So plus 1a and a minus 2a. Does that give me a negative 1a that I'm looking for? Yes. So these are my factors, okay? So let's see what this guy over here, do you understand what he factors into?
Yes, ma'am.
What does 2 sine squared factor into?
2
2 sine x and sine x. Are you with me? What's a minus sign at the end mean?
Opposite sign.
So plus and minus. Only factors of 1 are 1 and 1. So does a plus 1 sine x and a minus 2 sine x give you a negative 1 sine x?
No.
Yes?
Yes.
plus 1 sine x minus 2 sine x is a negative 1 sine x.
Oh, yeah.
Okay, so let's set each one equal to 0. Bailey?
The first one has 2 sines squared, and then the second
This,
one,
but when I multiply 2 sine by sine, I get 2 sine squared.
but then there's
Pretty
another
full.
sine x.
Yeah, because you multiply
Because the
1
inners
times
and the
sine.
outers give you the middle.
Okay, got it, sorry.
That's okay.
Yeah, baby.
Okay, you finish it. All right, you finish it. You're going to have 3 answers. 3 answers. This one's only going to have 1 answer. He's a quadrant angle.
I got one for that.
This one's going to have 2 answers.
Wait, how many answers we gonna get?
30.
This is it. You know what sucks is like you have a worse opinion. It's just bad because the camera. Wait, I got that wrong one.
Did you get 5 over 2?
So did you get 4
Yeah.
pi over 3?
No, I got pi over 6 and 5 pi over 6.
I didn't bring it to the nail over 6.
Yeah.
Oh. Oh.
Yo, if you're watching this YouTube video,
right now,
Stupid because I did pi over 3.
Hey guys, if you're watching this video in the future, just know that this class is not hard, but Ms. Davis loves to make it hard. So it's gonna be hard.
Yeah,
cool. Never trust anybody that has 48 subs.
I did not advise this class. Like, come at your
I got it right. At least whenever you do something, it looks
Oh, look, this is showing too. I got them in a little Chinese robe with
So
swords.
basically, one,
Heads up, boys.
the next day, I still know
This is all I got.
Sign is wide. Back up. If you watch this video this whole way, get your right hand.
That's my favorite spell.
Bella, do you have your units all? Do you have with you? Can I see it?
He was like, no.
I did that.
Somebody cut the video off.
Oh, I lose.
Hey, like, you might as well try to turn your
Hey, Sean, I play my pizza.
I will not turn it off. I know
She's way better than me.
I cut a ton of video off.
Hey, Sean, she's looking at us. I just so if you like this video, like and sub.
Turn on post
Notifications. Link in the bio.
Make sure you turn on post notifications. Make sure you like and subscribe. Let us know how we did in the comments. Let us know how you like this class. Click the link. Alright, catch you next time.
Do something.